real, the basic science, the basic fundamental concept of science. So that's a interesting set of problems. But today we have one problem. Talk a little bit. We have a problem with our climate and with the energy that we use. What is the problem? What are we doing wrong instead of causing the Earth? What are we doing wrong that's causing the Earth?
We're consuming too much of Mother Nature.
Consuming too much of what kind of stuff?
Oil.
Yeah. And what do they produce? What do we make that goes in the atmosphere? Carbon dioxide. The big problem is carbon dioxide. We're burning fossil fuels that are called coal and gas and petroleum. Oil, basically. Certainly like we're burning less of that this week. But the problem is we're burning so much fossil fuel that the amount of CO2, carbon dioxide, injecting into the atmosphere is causing the temperature to rise. So we can show that. This is actually the data on what's happening with CO2. And you can see it has a very cyclic thing that's depends on the time of the year. And that's the oscillation is year to year. When it's hot in the middle of summer, we burn a lot of electricity. We run our air conditioners. In the winter, we burn all the gas gas and coal to heat our places. So this thing also, but it's going up. You can see the concentration's gone up about 20% over this period of years, 40 years, 40, 50 years. And that's a problem. It's a serious problem. And so what does it mean? Here's something that means. This is a really cute experiment. Let's see if I can explain this experiment. This is an experiment in which you take two satellites and you put them out in orbit and you set up a means of measuring the distance between these two satellites. You can do this to better than a millimeter. Everybody knows what that is. To better than a millimeter, you measure the distance between these two satellites. Now, they go around and they go around several times. They go over, let's say Greenland. They go over Greenland and they measure the distance, Then they come around and do it again, and they do it again. And what they find is if the ice on Greenland melts, then what happens is the gravitational pull on the two satellites is different than it was before. So when they go around and the ice is melted, this guy goes up a little bit for higher than not quite like gravitational pull. And this guy measures its change in distance, and you can measure very precisely how much ice is melted on the thing. It's a really cute experiment, in my opinion, and fun thing to do. So this is what's happened. They measured this. They measured the amount of ice that has melted on Greenland and Antarctica. And what you see from this is that it's
you said the gravitational pull decreases as the milk.
Okay, so I have this big mound of ice here, right? Okay, so it would pull on something, pull it down, right? Try to pull it down. But if it melts and goes away, it doesn't, right? It's not there to melt it. It's gone, so it doesn't pull it down anymore, right? So the sunlight goes a little higher than might pull it on the previous rounds, right? Okay? That's how that works. So anyway, it measures this ice, this melting ice. The ice in Antarctica and Greenland is melting at a rate which is something like 1 millimeter of sea rise in the ocean every year. It doesn't sound like much, but it's a centimeter every 10 years, and 10 centimeters over 100 years, it starts adding up. And that's not the only place that things are melting. Things are melting in the Arctic and other places where there is permanent ice. And so the question is, can we live with this, right? And that's the thing that we try to figure out. There's a whole bunch of other things we can look at. Another way to look at the problem of why is CO2 a problem? Anybody know that? Yeah.
It's a greenhouse gas, so when it's emitted and it goes into the atmosphere, as it builds up, as the ultraviolet rays from the sun go into the atmosphere and they try to bounce back out so that the earth doesn't be too hot, the greenhouse gases trap them and it keeps the earth hot.
The ultraviolet rays, short-wave length of the ultraviolet rays come in, they get absorbed, and what comes back up is infrared radiation because it's polarized, and that stuff, the CO2 blocks, and that's how it works. So this is what you call what's called the driving force to increase the temperature, and we need to figure out how to counter that. And so what happens is if you look at, for instance, the sunlight coming in, you have this curve as a function of latitude. If you look at what's going out, you see that you're missing a piece here, and that excess up there is bigger than the thing on the side, and so that you end up with an unbalanced situation, and the Earth heats up. There's no choice. If we absorb more energy than we emit as an Earth, we get hotter. And it's just that simple. And so if you look at all the worst part is that it's not just CO2, it's also methane and nitrous oxide. These are also things that are very dangerous. They are certainly increasing. See this plot? Now, how many of you have seen those plots before? Good. These plots have been debated recently in the popular press because people claim that there are people who claim that these are not accurate, but that's not true. This plot is measured in thousands of places around the world. It's well established fact. So it's not. We can show this heat flow more vividly in terms of all the different things that have impacts. One of the things that you don't understand very well is what do clouds do? You ever think about trying to figure out what clouds do as far as reflecting light? Do they reflect more light down or more light up? And you look outside and look at clouds, you see, geez, there's all these hundreds of different shapes and very complicated stuff. How do you know what goes? Well, people have worked very hard on that problem, and we still don't know it very well. But we know it well enough that we believe that we can predict roughly what's happening. So it is depicted here. There's clouds and
sorry.
Whoa. And there's clouds stop the heat from going out, but they also reflect the heat back up, and that comes in. So all these things have to be balanced. So now we think that the world is not in balance, heating up. And there are claims by people out there that there isn't strong evidence of this heating because we didn't get any hotter in the last 10 years. Well, 10 years is a short period of time, and it is true. It hasn't gotten hot in the last 10 years. Look at this curve. It's not hot. Right? This is a curve of line curve sometimes. If you look historically, here's the historical temperatures. There are other periods of 10 years where you don't have an increase in temperature. Just from year to year, you have to wait a long time. All those years in between, the temperature is lower. So it isn't a question of 10 years, it's a question of 100 years is what's going to happen. And, so we all believe that we have to do something about this problem. The question is, what do we do and how do we solve it? It's something that everybody here is going to have to participate in eventually. So what would you suggest? What do you think we could do to burn less CO2 in the atmosphere? Quit driving cars? Don't think that's going to happen. No.
More people maybe taking the bus or the metro?
Pardon?
Maybe